Okay, so today we will talk about the wave particle nature of matter. And now we are entering into time in physics and in general in science where scientists were wondering and they were defending their theory supported by certain experiments. So it was, as we said, there was a debate between what is the light is a wave or is a particle. So there were different experiments that were supporting the wave nature of the light, and there were different experiments that were supporting the particle nature of light. And we saw in previous lessons, like double split Young's experiment that demonstrated the exhibited interference properties that were clearly showing that light is a wave. However, wave theory is not able to explain a lot of other phenomena like diffraction and interference of light, and especially the particle-like concepts of light is required to explain those phenomena, but most obvious experiment was the photoelectric effect, in which we said that it is as a result of the fact that the photon is a tiny massless particle that carries energy, and then when it is collided with the electron in the structure, it gives all this energy to the electron and then removes it. If it is big enough, removes it from the original structure, the electron, and then makes it move to the other plate. And also, the other experiment or finding was the emission and the absorption spectrum gamma radiation, as well as an experiment or a finding that can be only explained with the particle nature of light. So it seems that light can be as much particle as a wave, but which one is correct? The answer is they're both correct. So light can be a wave and a particle at the same time, and the properties will depend on the energy. Energies based on Planck's theory will be h times f or hc over lambda, and on the kind of experiment that we decide to conduct. So two are the factors that depends on what nature of light will appear. In general, the more energy photon has, the more as a particle it behaves. So when we have, here is like a schematic view of the electromagnetic radiation. When we have the electromagnetic radiation, the lower frequency are frequencies with radio waves, and then that means that they are more like the nature of the light is more like a wave nature. And when it moves to the higher frequency, which are X-ray, gamma ray, then more the particle nature of the light is dominant into the nature of the light. Okay, so notice here that we have an overlap, which part of it is the visible light as well. The visible light is the light that we see in life. As a human being, our eye is designed to see. And this is why we can see different nature, wave nature of the light or particle nature of the light, depending on the experiment that we are investigating. At the time, de Broglie, which is a French, educated in Sorbonne, he was very fascinated with the physics, even though that his main prior education was in history. So he was fascinated with physics. And when Compton suggested that X-ray scattering experiment, which, by the way, as a review, is explained with using the conservation law of momentum and giving the photon a part, considering it as a particle and giving it the attributes of momentum. De Broglie said that, okay, since photon is a particle that doesn't have mass, but is able to carry energy and momentum, then why not the electron, which was the smallest particle known at that time, because now we know that there are smaller particles than electron. So at that time, then he said that why not the electron is a particle, it's a particle and it's a wave. So acts as a particle and acts as a wave. Now, if it acts as a particle, we know that momentum of a particle object, an object, a matter that has a mass, based on the momentum and impulse unit, is calculated as mass times velocity. So when we see this as a momentum of a particle. And based on de Broglie's theory, what we have is that momentum of a photon is h over lambda. So when we see it as a photon, then we have h, which is the Planck's constant, and over lambda. So this is momentum of photon, which, remember what it is. It's a tiny massless particle that is able to carry energy. So by equaling those two equations together, we will have that mass times velocity is equal to h over lambda. And then from here, lambda will be h over mv. But now we know that when we are dealing with the light, the speed is the speed of light. So you can say is h over mc. Okay, so let's see case. If it is a different one, if it is, let's say in another medium, or if the electron is moving with a different speed, then we will have to consider whatever is the speed of it. But when we are dealing with light, then we just go h over mc. Okay, so let's calculate what is the wavelength that is associated with an electron that is moving at half of the speed of light. So the velocity of the electron is half of speed of light, which is 0.5 times 3.0 times 10 to the power of 8, or 1.50 times 10 to the power of 8 meters per second. And the wavelength when the electron is moving with that speed will be h over mv, h over mv, and then 6.63 times 10 to the power of negative 34 joules times seconds over mass of the electron, 9.11 times 10 to the power negative 31 times 1.50 times 10 to the power of 8. And then when you enter this in your calculator, you will see that the wavelength of an electron that is moving at the speed half of the speed of light is 4.85 times 10 to the power of negative 12 meters. So again, de Broglie said that since photon has energy even though it doesn't have mass, and has momentum even though it doesn't have mass, why not electron, that is a particle, have acts like a wave, have a wave nature of it. And this is how we calculate the wavelength of an electron that is moving at a certain speed. Now, if the electron is allocated to accelerate through a potential difference, let's say a potential difference of 150 volts, what is the de Broglie wavelength of the electron? So first of all, what we have to do is we have to find what is the speed, and we are assuming here that is accelerating from rest. Okay, so now based on the conservation law of energy, which is a principle, I mean one of the 10 principles on physics, we can say that kinetic energy of the electron is equal to the electric potential energy between the two parallel plates, or 1/2 mass of the electron, velocity of the electron to the power of 2 is equal to Q times E. And now since, Q times V, Q times V. Now, from here, we can find that the velocity of the electron will be the square root of 2 times Q, which is the elementary charge, times delta V over mass of the electron. Now, enter this in your calculator and figure out what it is. So in terms of numbers, this will be 2 times 1.60 times 10 to the power of negative 19 times 150 over 9.11 times 10 to the power of negative 31. And then when you enter this in your calculator, I have the velocity of the electron as 7.26 times 10 to the power of 246 meters per second. Now, based on the de Broglie wavelength formula, which again is proposing that electron is not just a particle, but it's a wave as well. So the wavelength will be h over mv, or 6.63 times 10 to the power of negative 34 over mass of the electron is 9.11 times 10 to the power of negative 31 times velocity is the velocity that we just found as 7.26 times 10 to the power of 6. Enter this in your calculator and see what is the wavelength. And I have the wavelength as 1.0 times 10 to the power of negative 10 meters. Okay, so now de Broglie now began to apply the wave nature of the electron to see what is happening. Why do we have those orbits at the hydrogen atom? Assuming that the electron, like as a wave in hydrogen atom, and we are talking about hydrogen atom because hydrogen is the easiest one that we can that we study. So if we understand that better, then we will have a better understanding of the other elements in the periodic table. So anyway, so he, assuming that the electron acts as a wave in the hydrogen atom rather than the particle, de Broglie began to try to fit his wavelength into the circle. And the electron acts like a standing wave, spread it into the circle of radius r. I will bring a picture here so we can explain it better. So those are the standing waves in a one-dimensional, and then as it goes into a circle, it becomes a standing wave in two dimensionals. So some waves fit and some do not. When a wave does not constructively close, so it's not a continuous loop that it's constructively closing into the circle, then when the wave does not, it interferes with itself and dies. Like in this example here, it's not a stable radius in which the electron can orbit. However, if the two-dimensional standing waves that the electron is having is into it's forming a constructive interference, then the energy level is stable. This is pretty much what de Broglie is saying, and then now we know that when we the perimeter of or the circumference of a circle is 2 pi r, and in order to have a constructive interference, you have to have a whole number of wavelengths so that they are obtaining the circle. So n has to be a whole number, positive whole number. So then from here, and wavelength will be equals to 2 pi r over n. And combine this with the de Broglie equation that wavelength is h over mv, we can figure out that 2 pi r over n is equal to h mv, or in other words, mvr is equal to nh over 2 pi. So this is the mathematical form of one of the Bohr's postulates, that an electron can only have a discrete stationary orbit. So through this work, what de Broglie did, it's prove mathematically that Bohr is one of the postulates of Bohr is correct. De Broglie's relationship for the electron acting as a wave in an orbit allow us to derive Bohr's equation when n is Bohr's primary quantum number for the energy level. Further, the idea that electrons within the atom behave as a wave rather as orbiting particles explains why they do not continuously radiate electromagnetic energy. Okay, so now this part, the part that we will do now, it's kind of outside the curriculum. So if the wavelength of an electron in an atom is, let's say 2.0, if the wavelength of an electron is, but this is the end of the physics 30. So this is telling us that the fact that the electron, it's in a stationary discrete orbit, it's proven by de Broglie, which is telling us that even electron has a second nature. And at that time, the electron was the smallest particle. has a double nature, wave and particle, and when the electron is obtaining, as it is moving into a standing wave in the orbit, obtaining a constructive interference, then the orbit is stable and it doesn't radiate any electromagnetic energy. So the part here, you may not even watch it if you don't want. So now we have the wavelength of the electron is 2.0 times 10 to the power of negative 10 meters. What is the smallest allowable radius for this electron? So what is the radius of this electron? Now, as we said, the circumference of the circle is 2 pi r, and this has to be a constructive interference. Since n is equal to 1, because we are dealing with the smallest one, the smallest allowable orbital radius, then n will be equals to 1. So from here we can say that radius is equal to 1 times lambda over 2 pi, or 1 times 2.0 times 10 to the power of negative 10 over 2 times pi. So the smallest radius will be negative 11 meters. De Broglie also checked his idea by substituting Bohr energy level of the electron in the first energy level of the hydrogen, that is, in the previous video, 13.6 electron volts. So first, let's convert 13.6 electron volts into joules. So 13.6 electron volts times 1.60 times 10 to the power of negative 19 will be, to convert it into joules, will be 2.176 times 10 to the power of negative 18 joules. Now let's find the speed of the electron in the first energy level. So let's find the speed of electron in the first energy level, first orbit, for the first energy level orbit, okay? So first, in the first energy level. So now we know that the energy, electron of that energy level is carrying a 2.167 times 10 to the power of negative 18 joules. Now, the electron being a particle, the kinetic energy is 1/2 mass velocity squared, and this is equal to 2.176 times 10 to the power of negative 18 joules. From here, we find that the velocity of the electron is 2 times 2.167 times 10 to the power negative 18 over the mass as 9.11 times 10 to the power negative 31. And when you enter this in your calculator, you will find that the velocity is equal to 2.187 times 10 to the power of 6 meters per second. Okay, now let's find the associated radius based on the de Broglie principle. Let's find the associated radius, knowing that we are dealing with a first energy level. Okay, so radius will be n over mv times h over 2 pi, which is known as hash h. You will see this when you go to higher level. So now, since n is equal to 1, 9.11 times 10 to the power negative 31 times 2.187 times 10 to the power 6 times 6.63 times 10 to the power of negative 34 over 2 pi. And then we will have the radius, that is 5.3 times 10 to the power of negative 11 meters, which is the same as the radius that Bohr calculated for the hydrogen, the first energy level of the hydrogen atom. Okay. Now, if we take a look at the double slit interference of particles, then we will see, and I will post a video about this, we will see that when we have one electron in the double slit, then the electron chooses one of the slits. But when the number of electrons is increased even more, then we will not quite see. Some of them will choose to go to slit 1 and some of them will choose to go to slit 2. However, when the number of electrons is increased too much, close to 100,000 electrons, then we will see an interference pattern. So particle waves are waves of probability. This is another concept of what was introduced to the world at that time. And then Heisenberg presented that is known now as the Heisenberg's uncertainty principle. Okay, we'll talk more about this if you feel interested in class. However, for now, this is the end of this video.